Okay, everybody, this is the first of 5 videos going over the expedition's notes. Remind us to due on Monday you get back. 5.5 and 5.6 are required. X.1 through X.3 are strongly recommended, and I expect most of you to do them. Okay, we're going to start off with 5.5, Fundamental Theorem of Calculus Review. Now, some of you may have already gotten to the problems. I just want to go over what is Fundamental Theorem of Calculus. You've heard it before. What is it? And the thing is, fundamental theorem of calculus is two parts, and I think that's what also confuses students. We have part one, which says that the derivative of an integral from a constant to x of some function is the inside function. That's what that one is. Remember that? And that's usually, this is more like, this will be multiple choice questions that are kind of asking you about a certain function, or like what it's doing, or when does it have inflection points, and you have to know that this is true to sort of to access that. The derivative of an integral is the inside function. That's FTC part one. There's a corollary to this, which we learned recently, and a corollary, I don't think I'm gonna spell this right. Corollary to FTC part one, and we did this very recently. This is the one where if you have the same thing, a derivative of a function, but this time it's from like g of x to h of x of some f of t dt. Right. So the change here is that instead of a constant to a value, it's a function to a function. Then the answer to this would be, zoom in a little bit here. Okay. Yeah. Would be f of h of x times h prime of x minus f of g of x times g prime of x. That's the corollary. So these have to do more with, I don't want to say conceptual, but these are more to do with function analysis, so like analyzing a specific function and what it's doing. What these problems are down below, when you have the definite integral, that's FTC part 2. So FTC part 2 is specifically referring to definite integrals, although you can use part 2 to get, that's how we get these to begin with. I'm not going to go into that now, but that how we got this originally was using part 2. Anyway, FTC part 2 says that if you have the integral from a to b of some f of x dx, this is just equal to the antiderivative at b minus the antiderivative at a. So to apply fundamental theorem of calculus part 2, to find a definite integral, you take the antiderivative, right? The steps are take antiderivative, right? That's your first step. And then 2 is take the difference, which is f of b minus f of a. Okay, so let's do some practice problems here. So down below, these are all different applications of that idea. For the first one here, this is review. We did this in Unit 3. So first step, get the antiderivative. This is using the basic integral. I'll put that right here. The integral of x to the n is x to the n plus 1 over n plus 1 plus c. That's the integral. See, it's the reverse power rule. So here it would be 3x to the third over 3 minus 4x squared over 2 from 2 to 3. Right? That's the first step. So then we're going to do, you just plug it in. So it's going to be, those 3's will cancel, so it's just going to be 3 to the third minus 2 times 2 squared, right? I simplified this a little bit, right? Because these 3's cancel, and that will become a 2 right here when you simplify it. So I applied that minus, sorry, this is a 3, my bad, minus 2 to the 8th minus 2 times 2 squared. Did I say 2 to the 8th? 2 to the third. Anyway, okay, so we have 27 minus 18 minus 8 minus 8. So this is just 9 because that's just 0 and that's 9. So 9 minus 0 is 9. Okay, that's fundamental calculus. We used this a lot in the next 2 units. Unit 6 and 7 is all about integration. So you're doing a lot of this. You're doing a lot of integration. You're finding antiderivative, and sometimes you'll be doing this. Sometimes you'll just be finding the antiderivative as it is. Anyway, we'll keep going here. This is what I talked about over the at the end of Unit 5. I cut this from the test because I was like, okay, I'm just going to do this over expeditions because I don't want to overload you at the end. This applies what we just reviewed to what we learned last unit. You want to find the average value, okay? Remember, the formula for average value is 1 over b minus a integral a to b f of x dx. You gotta know that, gotta memorize that, right? If you ever see the words average value, you're thinking this formula, right? So in this case, it's gonna be 1 over 2, because 1 minus negative 1 is 2, right? Integral negative 1 to 1 x squared plus 2 dx. So basically, this is just like the first practice problem, except with this 1/2 at the beginning. That's it. It's the same thing, just 1/2 at the beginning. That's all you got to do. So same thing, antiderivative, x to the third over 3 plus 2x from negative 1 to 1, and then we'll do the 1/2 at the end. Essentially, think of it like this: you're gonna find whatever this antiderivative, whatever this difference is, and then you'll multiply by 1/2. So it's gonna be 1/3 plus 2 minus negative 1/3 minus 2. So that's 2 1/3 minus negative 2 1/3. So we're going to get 4 2/3. Which is the same as 14/3. Right, I just multiplied 4 top and bottom by 3. And 12 plus 2 is 14, so it's 14/3. So what we have over here is 1/2 times 14/3. So the answer is 14 over 6. Okay, so to do these, you anti-differentiate. It's the same steps here. You take the antiderivative, you take the difference, and then you just multiply by that 1 over b minus a. You're just doing that last. Okay, so it's antiderivative. Make sure I did this right. Antiderivative, difference, plug in the 1, plug in the negative 1, take the difference. Once you've got that difference, 14 over 3, you multiply it by 1/2, and you have 14 over 6. Okay. Last one. These are these are similar. The only difference with these is that they're piecewise. So when they're piecewise, you have to do 2 separate integrals for each part. You can imagine it. This is not really what it looks like, but this integral might look something like this. It might be, something like this, right? This is the negative 12x plus 6 part, and then all of a sudden it goes like this, right? That's kind of how this looks, and you want the area from negative 1 to 2. So you're trying to find this shaded region. So it's okay that it's separate. It's okay that it's not connected. We don't care. It's not. We're not. This isn't about the derivative. This isn't about intermediate value theorem. We don't care that it's continuous, that it's not continuous or not differentiable. Like, that's okay. We can still integrate those parts individually, and that's what you do. you're integrating this function on this interval and this function on this interval, and you add them together, right? So here I want the average value of f of x from -1 to 2. Well, that just means 1 over 3, because that's the distance. 2 minus -1 is 3. Integral -1 to 2 of f of x dx. The challenge with this one is that this then is going to separate into two intervals here. So it's going to be 1/3 times, like this is like one big parentheses here, integral -1 to 0 of this one, -12x plus 6 dx, plus the integral from 0 to 2 of this one, because it's for x is greater than or equal to 0. Okay. Does that make sense? So it's, again, these all kind of build on each other. The first one's most basic, then you added average value, and this one you have to do two separate intervals. So we just do it twice. So we have here, we're going to have negative 6x squared plus 6x from -1 to 0. And then we're going to add 2x to the third minus x squared from 0 to 2. And so that's going to be 0. So this one's going to be 0 minus, then we're going to plug a -1 in. So it's going to be -6 minus 6. That's -12. So this is just 12. Plus, then this one's going to be, plug in that 2, that's 8, that's 16. 16 minus 4, it's 12. 12, this is just 0. This is just 12 right here. So it's 12 is 12. That's 24. Then I got to multiply by the 1/3 from before. So 24 times a third is 8. Okay, the answer to that one's 8. So for piecewise, separate into two separate intervals, do them separately, then multiply it if needed by that at the end. Remember, you only have to do average value if it says average value. If it doesn't say average value, you don't need to do the 1 over b minus a. You would just do the regular integral. Okay, that's it. That's 5.5.